science does make mistakes. It's not dogma, but hopefully we find these mistakes and we correct them as soon as possible. And we change course and we have a new plan based on the new information. I think that would build more trust, which unfortunately we are losing currently in large segments of the community.
Welcome to Inside Policy Talks, the podcast of the Macdonald-Laurier Institute. I'm Peter Copeland, Deputy Director of Domestic Policy here at MLI. Science is often seen as the gold standard in policymaking, objective, rigorous, and self-correcting. But what happens when the science itself is uncertain, contradictory, or unable to be reproduced? Over the past decades, concerns about replication, statistical misuse, and institutional bias have shaken confidence in science, from medicine to psychology to public health. Yet, institutional confidence in science seems unshakable. And with rising polarization and decreasing trust in institutions, the need for epistemic humility and stronger standards of evidence has never been clearer. Today's guest is one of the world's most cited and most courageous scientific voices confronting these challenges. Dr. John Ioannidis is Professor of Medicine, Epidemiology, and Population Health at Stanford University. His landmark 2005 paper, Why Most Published Research Findings Are False, helped spark the understanding of the replication crisis in science, and it remains one of the most widely viewed and cited medical articles of all time. Dr. Ioannidis has written extensively on statistical misuse, social pressures that distort research, and how we can improve the reliability of scientific knowledge, especially when it's used to guide public policy. And as someone who cares deeply about how we make sound decisions in an age of information overload and institutional distrust, I found his work indispensable to understanding both the promise and the limits of evidence-based policy. Before we get started, I just want to remind everyone to please remember to like and subscribe. It really helps us reach more people with these ideas. Without further ado, John, welcome to the podcast.
Thank you very much for the very kind invitation. It's a great pleasure to join you.
Great. Let's dive right into it. Beginning with this famous 2005 paper, Why Most Published Research Findings Are False. Quite the title. Maybe you can share how that title got selected. First, what did it say, first of all? And then let's just talk about its reception nearly 20 years on. What's changed? What hasn't?
The paper was an effort to calculate what are the chances under different circumstances of different priors for having the ability to detect true findings, different sample size, different power considerations in different fields that often struggle with pretty small studies because they have very limited resources or funds or fragmentation, different biases that may affect, again, different fields, different conflicts potentially, and also an increasing number of scientists attacking sometimes the same or similar scientific questions in a kind of competitive way rather than joining forces, each one of them trying to outpace the others. How likely it is to get true versus false discovered signals. And it showed that under most circumstances of how most scientific fields work, given their signature of these parameters, it's more likely to get a discovery that is not really a genuine discovery, but it's a false finding, a false positive, rather than one that is genuine. So, as you said, 20 years have passed since then. I think we had some empirical documentation that this is likely to be the case back then, but it was scattered across a number of fields and missing empirical evidence in many others. I think we have collected empirical evidence in a much larger number of fields with different ways, sometimes with direct replication efforts like reproducibility checks, where people try to put forth some of the creme de la creme research that has been published in their field and try to replicate it as rigorously as they can. Most of the time, that doesn't work, or with other indirect means of trying to understand how likely are the effects that are circulating in the literature to be true. Lots of things have changed also in the way that science is being done. So several fields have improved over time, or have put forth different approaches and research practices that try to safeguard from some of the biases, eliminate them, prevent them, correct, at least after the fact. At the same time, we have seen a very rapid growth of the scientific literature, and a growth mostly of literature that is not very strong in terms of methods, quality controls, rigor. Uh, we have an onslaught of very poorly done work that is being published in a very large number of journals, including also predatory journals, and including now even completely fake products of AI. So, on top of the old problems, which we have been struggling to deal with, we also have new ones that are accumulating probably a larger number of very problematic or even completely wrong and fake papers.
Right. Yeah. So good to see there have been improvements, but yes, major challenges and new ones remain. I wonder if you can help me parse a bit. To what extent is this issue concentrated in the social sciences, where certain factors that just make it very difficult to, using the methodological constraints that I should say maybe first arose in the physical sciences and might be better suited to their use there. Um, to what extent that it's confined to these areas in which, you're dealing with psychology, you're dealing with, variables that are difficult to operationalize according to very rigorous definitions and criteria. What would you say in that regard?
There's different biases and different challenges in different scientific fields. Of course, we cannot generalize that you have the same pattern of failed replication or problems with biases, with conflicts, with the way that research is operationalized across every single scientific field. But I think by now, problems have been documented across almost any scientific field, both in the social sciences and biomedical sciences, and even physical sciences. Physical sciences, some of them may be protected from some types of bias. For example, very often in the social sciences, but also in biomedicine, we struggle with small sample sizes. And this may not be an issue in some of the physical sciences, like those who work in astronomy with telescopes, or scientists who work at CERN with very, very large amounts of data in particle physics. uh, Small sample size is not the issue. It's exactly the opposite problem, having too much information and not knowing what to do with it, which can also create its own challenges. But in the big picture, we have seen problems across the board, and I don't think that we should single out social sciences. Um, Biomedicine, for example, life science, medicine, biology, and related fields are approximately 50% of the entire scientific literature of about 7 million papers per year. And we see very prominent problems in practically every single field that we touch to try to understand its replication patterns and features and biases whenever we probe it. This doesn't mean that some fields are not better than others, or are more protected, or are more likely to have taken steps to improve things. And there is a lot of heterogeneity. Even the same field may evolve over time. Genetic epidemiology used to be a very low replication field. In the Canada genera, people were coming up with one hypothesis at a time, or a few hypotheses at a time, trying to pick what biology might suggest in terms of a gene that may affect some phenotype, some disease, or some other condition. 99% of that literature could not be replicated. Then we moved on with better statistics, much larger sample sizes, more rigorous approaches. Replication is a sine qua non. 99% of what was discovered in that framework could be replicated. So in the same field, we had very rapid and massive change in the replication potential. Such massive changes have not happened in most fields. I think most fields have seen incremental benefits with some practices being adopted, and others, as I said, have just grown to very large proportions, publishing huge numbers of papers that
Hmm.
are still failing in very essential safeguards.
Fascinating. So I'm glad you mentioned this example, biomedicine, where because I think it highlights some of the challenges associated with the use of statistical significance broadly, which is correlational. But in fields like this, you're able more clearly to identify all of the mechanisms and steps in the causal process, so to speak, so that you're not relying on the use of various statistical measures to try to, without understanding the causes, reduce the possibility of error, right, and establish strong correlations. So how much of the problem in some fields, I know I'm overgeneralizing with my questions, but you can clarify, is due to this over reliance on statistical significance and p-values and things of this nature?
I think it's partly implicated in what we get in the literature being non-reproducible, but I think that the problem would have persisted even if we had used different statistical methods. For example, I believe that we should use more Bayesian approaches rather than frequentist with p-values. Uh, but I have to say that if we were to suddenly switch somehow to just Bayesian thinking and implementation, probably there would still be ways that some of the biases, some of the chasing of a significant result would still be there. So the incentives are such that investigators are told that you need to find something that seems to be important, something that it has impact, something that makes a difference. Now, um, whether people use null hypothesis significance testing or Bayesian statistics or some other inferential tool, false discovery rates, some may be more appropriate, more fit for purpose, but I think that they could still be manipulated, they could still be gamed, and we would still get the same problem. Inserting more causal inference and more causal thinking probably would work. To be honest, we haven't been able to document with very strong evidence that that's the case. Intuitively, it makes sense. Um, the challenge is that in most of the questions that we're after in most scientific fields, it's very difficult to have very robust causal inference documentation. The phenomena that we study are increasingly very complex. We have very little insight about what the exact causal relationships might be. It's very likely that if there are causal relationships, which even that might be challenged, exactly what we mean by that, they're likely not to be so consistent. They're likely to be very fragile. They're likely to be dependent on very small perturbations at time. Even chaotic type of phenomena may be prevalent in lots of the things that we study. So very often people try to insert some causal thinking, but it tends to be very naive, very superficial, and it makes things worse because then it creates a narrative of causation that may be under representing reality, and it leads to even more incentives to fit results to that narrative. So people try to fit the results to the narrative, which means that they're not objective any longer, and we get literatures that become more like bubbles that try to serve some causal narrative that is not very well thought of.
Fascinating. So it strikes me as this, this famous expression, correlation does not equal causation. Um, what may have been going on is that, in spite of the warnings, seldom hewed to, one can't help but interpret research findings this way. It's how they're presented. It's kind of natural that, one would hope anyway, if one's field is doing its job, that the correlations are at least getting you to a causal understanding of the world. But as you say, what I found was really interesting. If you find causal relationships, they're likely to be quite nuanced and particular, which I think in fact, is revelatory of a deeper point about the philosophy of science and the way in which we understand the makeup of the physical world, whether in fact one can generalize, um, fairly general causal rules about how things interact. Whereas in fact, it may be you may be able to establish a number of causal relationships more or less, but then when you drill down further, everything is quite particular and not able to be, using some of these standards you've highlighted, fully replicable, fully generalizable, all of these sorts of things. So I'm wondering if you could just comment on that reflection. Does that strike you as apt and part of the story here?
I think it is. Clearly, we're dealing with complex phenomena very often that have a lot of heterogeneity, a lot of variability that is inherent to them. And as I said, they may change in different circumstances, in different settings, in different populations, different people, single people, when it comes to biology and medicine and intervention. So that has led also to a substantial amount of effort to try to individualize or to personalize science. Especially in medicine, this has become kind of a bandwagon effort in the last 20 years or so. Uh, Personalized medicine and personalized interventions, trying to find the silver bullet for each one of us, which might be different from what would be for other people. And there has been some progress in that regard, but not as much as we would have hoped, because in some cases we could identify some of these very, very special single person or single set of circumstances type of effects. For example, monogenetic diseases. Someone has a gene in a variant, in a mode, or in a mutation that is conferring such a strong impact on what they will get. They will get a disease no matter what. It's a very strong effect. But these situations account for a pretty small minority of what we experience. For most of the common things that we care, and I'm talking about medicine here, but I think the same can be said of other fields where we might be interested in behavioral phenomena or group community phenomena, and
Right.
even policy decisions at
Yes.
a country or global level. Uh, the situation is far more complex, and it's not easy to identify these silver bullets. Perhaps they don't even exist. So we are stuck with trying to understand averages. And I think that if we could understand averages with some fair accuracy and lack of bias, it would be an important step. Many people would not be happy, but I would be happy because it's a first step. And it could be helpful for decision making. On average, we would do more good than harm, probably, if we are accurate about that. And at the second level, try to understand more specific effects at a level of subsets, so all the way to individuals and single settings, which would be ideal. But I think that currently most of our efforts are not really well equipped, and they lead to even more flawed literature because people think that they have found this type of effects, but in fact, they're generated from an environment of even more underpowered research, even more biased, even more narrative driven,
Mm.
and conflicted, and therefore it seems to be even less reliable than the average type of
Huh.
science.
Yeah, so we're going to get to the epistemic stance one should adopt in light of all of this nuance with respect to what science can shed on complex questions. But before we do, I just want to return to this methodological point about statistical methods versus causal inference and modeling, because you said it's kind of easy to adopt the causal language while not doing the due diligence to ensure one's methods are rigorous. So um, my understanding is that it was developed rigorously in the context of smoking interventions, kind of originally. So you try to understand the different nodes, so to speak, that could affect an outcome based on, a particular intervention, and then you try to use Bayesian methods and asking counterfactual questions about, what would happen here if this and that, then use mathematical techniques to try to establish the causal patterns. Can you speak to like the benefits of doing this? Which sort of fields this might be amenable to this sort of technique, and in particular, any in the area of social science and social policy? I note that it's been some recent economics Nobel Prize winners have used these techniques.
I think that it boils down to how strong are the instruments that we have for answering specific questions in specific topics. For example, if one uses instrumental variables, if you have weak instruments or instruments that are not specific, that is not really very helpful. Um, if we use other methods, again, it depends on how much they can capture the complexity of the problem properly, and how much do we know about how to build that specific structure. Sometimes we know quite a bit, but other times we do not. There has been some empirical validation of some of these methods versus, let's say, purely experimental methods like randomized trials. Most of these validations actually are not very fair because they somehow know the answer in both methods, and they try to show that they somehow agree. Oh, look at that. This trial emulation based on observational data gives the same result as a randomized trial. If only we knew that we had to select this population and select these interventions and select these other factors, then we would get a very nice, clean answer. But this is a bit after the fact. It's kind of justifying something that we have already observed. So even though I do believe that some of these tools have value, and in some cases they may be the only ones that we have because we would not be able to run randomized trials, for things that we feel might be harmful. It is unethical. There's no equipoise to perform randomized trials. And even for things that there is equipoise, I think that there may be reasons that randomized trials may not be easy to do, or may not give the full picture, or may not be able to cover every set of circumstances, or may have other biases of their own. I think they are useful to have in our armamentarium, these options, but it's not that they're bulletproof. It is just one more way at trying to dissect effects, especially effects that might have implications for policy and for action and for decision making. I think that I don't want to put a single number on their credibility. It can vary depending on how they're implemented and how strong is the substrate that we feed them. In some cases, I think they will work, but not every single time. So we have to still be cautious and try to understand better what they do and what they do not do well.
Hmm. Yeah, well, I can see all of those points. I tend to think that just the difficulty of employing all of these techniques to ensure, degree of rigor and approaching certainty for for what one's measuring is just so difficult in practice. But in fact, the philosophical picture makes a lot of sense to me. And that's what I want to ask you about just quickly before we move to policy. We've been operating with, since the scientific revolution, more or less, a certain metaphysical picture of the world, one in which we think that all higher order physical systems are reducible to their parts, that they have a kind of billiard ball style, efficient causation. Um, Everything can be explained this way. Fundamental particles interacting with a few forces, and that we can understand, nature according to these laws, and then and determinism is another kind of assumption here. And then you've referenced some of these terms already, the hypothetico-deductive model. So you state your hypothesis and deduce therefrom, again closely related to the deterministic picture. This focus on falsification and replicability and generalizability. These are all kind of the tools that seem to emerge from my perspective from this metaphysical picture. Um, but I'm wondering if you think it's a bit oversimplified or a bit incomplete. We've found, in the past century that quantum physics at this level of reality, causation, is probabilistic. It's not fully deterministic. There are emergent properties in chemistry in larger order systems or lenses of understanding, um, phase transitions and boundary phenomena in physical systems. We see, I think, increasing evidence that causality isn't always linear or bottom up. It sometimes can be holistic, relational, or even top down in nature. The properties of the whole end up exerting causal force on the parts. And so this challenges reductionism and determinism and this sort of thing. So my question is, does this deeper deeper set of assumptions about the nature of reality, is it part of this replication crisis and overconfidence in statistics and this sort of thing, and are we starting to see a shift in our understanding or fundamental assumptions about how nature operates?
I think that most of our research is trying to achieve approximations at best. So, phenomena may be far more complex than we try to probe. But this doesn't mean necessarily that I would explain away lack of replication to be due to these deeper complexities. I
Mm,
think it's more naive and simple explanations, usually bias and error, and artifacts and unfortunately even fraud in some cases, rather than these deeper layers of understanding that in some cases we may have tools to try to approach them a bit more efficiently. I think that some of the obstacles that were posed by computational capacity in the past have been gradually overcome. So lots of questions that were out of reach because we just didn't have good enough computers, we didn't have good enough analytical tools to approach them. That is no longer that much of an issue. And I think that
mhm,
some of that improvement in capacity of computation and analytical brute force may help to solve some of the problems that have been pretty recalcitrant. One example is the latest Nobel Prize on understanding protein structure. Basically, it was an issue of having enough computational capacity, and AlphaFold could make that difference that for
mhm,
decades scientists could not really make much progress. In other areas, especially when there's phenomena that are not just an issue of just trying to tackle lots of measurements, but even trying to understand what to measure, how to measure, how to basically reliably measure. And when it comes to behavior and a lot of complex biology as opposed to just molecules,
mhm,
then that's still, I think, the major problem. I think that our ability to measure with sufficient construct validity and even face validity and also error that is acceptable, and to restrict biases, sometimes very naive biases, like
mhm,
you know pure allegiance bias or confirmation bias that may be the same sort that we had for centuries. I think that
mhm,
these remain still the key challenges to get rid of, and this is why many of the solutions are still targeting these types of problems. I'm not going to say no to targeting other types of challenges, and I think we do try to cover all bases, depending on what tools we have, what analytical tools, what data sets we can put together, what resources we have. Lots of science, unfortunately, is underfunded, so we can only get very limited steps based on the resources that we have. But I think it would be wrong to seek directly these far more complex, deeper issues, which are there. I'm not going to question that, and forget about some very easy, or well, I shouldn't say easy, but low hanging fruit that are in front of us, and we should try to get rid of these issues first.
Hmm. Fascinating. Okay, let's shift to the policy landscape. Evidence-based policy. This is a buzzword used in just about every domain in question, and of course, it's a good thing to aspire to. Um, but of course, the flip side of that is the overconfidence and perhaps assuming more certainty than the evidence warrants. So, what's your understanding of this term and its applications, and what do you think are the benefits of going for it, and then the limits of applying it in practice?
Evidence-based was a term that initially met with a lot of resistance when it was first introduced more than 30 years ago by the McMaster team, and others like myself espoused it. I think that it was seen as kind of a revolution because it was challenging expertise. Practically we were saying we want scientific evidence, rigorous, unbiased, systematically assessed scientific evidence instead of just expert opinion. And of course, experts have always been very powerful in most scientific fields. They run the show. So it took a while to reverse that climate, and then gradually evidence-based medicine, public health, decision making, whatever, became so popular and so powerful that everyone wanted to use the term to gain some prestige out of using the term. So experts started using the term evidence-based, and politicians and policymakers started to use the term evidence-based as an alibi, as an excuse that what they say and what they do and what they decide must be correct, must be really the best choice. And that, in fact, was often dissociated from real evidence-based. It was
Right.
expert-based, assuming the terminology just to gain prestige again, but it was not evidence-based. And most of the decisions and actions and interventions across most fields and across also interventions that affect the community or populations or policy are not evidence-based. They're claimed to be evidence-based. They're not. They're just justified as evidence-based, even though when you look carefully, so what is the evidence? You see that there's very little, and often what little there is highly conflicted or highly problematic.
Mhm.
But somehow it's a good word to use. um,
Right.
so
Right.
it is a misnomer most of the time. When I say evidence-based medicine, I start questioning. Oh goodness, not again. That seems to be another misuse of the term.
Yes, well, like all good things, it attracts imitation, but sometimes not the imitation you want. Um, so, one question about the relationship between evidence and policy, there's a famous kind of fact value distinction and all of these uh, methodological issues about the extent to which, a pool of evidence can then fully justify, some course of practical action, because there are a lot of value considerations in place, which I certainly don't think are subjective or anything like that. I think you can reason well about them, but certainly not in the same kind of way in which the evidence is, collected, is different sort of questions, right? And so, how do you understand that kind of connection between, you know, having an evidence-based approach to want to ensure that you fully understand, to the extent possible, kind of the domain in question, and then how that leads to the decision making and how it interacts with other types of reasoning about values, what have you?
I think that decision making is far more complex than just generating, synthesizing, and putting together evidence. We need to do these steps to collect, to synthesize, to analyze, to try to put together and see what we know, what we don't know, what we're missing, what are average effects, what is heterogeneity, what are potential biases. So this hopefully can be done in a fairly objective way, even though there are many steps that decisions need to be made about what to collect, how to collect, in terms of information, how to synthesize it, how to analyze it. So even that carries some uncertainty and also some subjectivity, where people may make their own choices in the nodes of choice that lead to a picture that is congruent with what they want to get. But let's say that this is done faithfully, properly, and without bias, which is the optimal situation. Decisions then need to be made that need to take into account far more other many other considerations that are not so easy to put in a box. It depends on who is affected by these decisions. If it's medicine, it could be the patients being affected. If it's a community, it could be that the community is affected, or a whole country, or it could be enterprises, it could be businesses, it could be uh, different types of entities. And then you need to try to take into account what are the preferences, what are the beliefs, what are the priorities, what is the value system, what do people think is important for them. So in the simplest of circumstances, where you have an intervention to be decided for a patient, you need to ask the patient what is important for them, and it would be different for different patients. They will value different outcomes very differently. Some will think that one outcome is horrible, and others will say, I'm okay with that, but I don't want that other thing to happen to me. They may be cost considerations, they may be ethical values, they may be things that are very circumstantial and context dependent. I prefer this now. If it were last year when I had a different set of circumstances, maybe I would have preferred something else. And I think that we need to visit that with care and with respect to whoever is involved and whoever will be affected by these decisions. Many of the decisions spill over to many people, not just single individuals. Some of the decisions affect our whole world in a way. So again, we need to ask who are those who are going to be affected, and then what is their value system? What do they care about? What do they want to get? Why? How do they prioritize things? How do they see life and different aspects of life? Because some of our decisions that are influenced by science can really improve our lives, or devastate our lives if we do things wrong. And it just has to be fair, open, transparent, um, justified, and of course, someone needs to make a decision at the end. Some decisions will be better than others. Some will be serving the common good. Others will be serving some private interests, and others will be somewhere in between. So at least we need transparency, and then
Yeah.
people can see what happened and why.
Yeah. Yeah, I can see this kind of orientation to ensuring that you're in good faith, collecting as much evidence, as is reasonable, and then on the basis of its quality, having the appropriate degree of confidence um, in the way in which you present that justification and in communication of a policy intention, all this sort of thing. And of course, in reality, what is often happening is experts have said, or put the label on it, so to speak, and then some course of action is justified. And again, recognizing that there is this sometimes fairly significant gap between an evidence base that could support some course of action. um, I'm just wondering then, what do you think, how do you think this should be done? How do you think this sort of thing should be carried out? What sort of things do you emphasize, like the means of communication? Um, you've already mentioned transparency, humility.
There's no perfect recipe, but I think that we should try to be objective and unbiased in collecting and analyzing the evidence, and this unfortunately does not happen very often, because stakeholders who want to shape a specific decision for their interests, they will probably try to subvert the evidence. They will try to sponsor studies that will get results that they like. They will try to read the results in the way that they prefer. They will select outcomes that are aligned with their own interests. But let's say that we try to do that, and we try to generate evidence that is unconflicted and objective. then we have that body of evidence that usually carries substantial uncertainty. Sometimes there may be a lot of uncertainty, other times maybe very little. Most of the time, there's quite a bit. And I think that we should be very honest to provide the appropriate level of uncertainty to those who we communicate with. And that includes the policy makers, the general population, or whoever is going to be affected by that policy. We need to say that, make a convincing case that we try to help them, which we try to serve the common good, which as I said, may not be the case, unfortunately, in decisions. And then explain that this is what we know, and we know that with that level of certainty, and there's still that big part or small part or modest part that is unknown, and it may change, and we may need to monitor some of that data or evidence as it accrues or it gets modified, and we may need to revisit that. So try to be honest about the amount of uncertainty. Try to engage people who are affected or who will be affected. Try to hear their preferences, their
Mhm.
viewpoints, and
Yeah.
eventually someone needs to make a decision. So I think that we cannot just say we don't decide
Yeah.
because we have uncertainty. Some will make decisions even with tremendous uncertainty at times.
Yeah.
But if that communication includes that transparency, that effort to be unbiased, and that effort to confer how much uncertainty we have, and be convincing that we do care for you, hopefully it will be fine. Even if it is the wrong choice, people will say, okay, we are humans, we make errors, science does make mistakes. It's not dogma, but hopefully we find these mistakes and we correct them as soon as possible, and we change course, and we have a new plan based on the new information. I think that that would build more trust, which unfortunately we are losing currently in
Yeah.
large segments of the community.
Yeah, it's fascinating because the what many people are looking for, we're all looking for really to varying degree, is confidence, right? In what we're putting forward, and it seems so starkly contrasting both to the way I think, unfortunately, various aspects of the scientific community have been presenting their findings, and certainly politicians in public policy landscape. It's the more confidence and certainty you can communicate, the better, right? And any sign or acknowledgement of some gaps, it leads to holes that can be poked by one's opposition. But of course, with maturity and wisdom, people do come to learn these things, and maybe in their own private lives in various ways, right? That people who sound like that are in fact overselling it and what have you. And I do think that's kind of what you're seeing right now in a lot of different areas, that there have been these big kind of scandals of overconfidence, in areas of science or in public policy or what have you. So let's talk about a few of those. um, I'll ask you, what are some examples that come to mind in recent years, past decade, of issues with confidence in science, how it's been communicated?
I think that different fields in science have created a different legacy for themselves.
Hmm.
And that legacy, unfortunately, may not be very positive, or it could be positive for some others. You take nutrition science, for example, which includes tens of thousands of well-intentioned and well-educated scientists who are trying to do good work. But the eventual composite that emerges and is being communicated through guidelines, through booksellers, through recommendations, through expert talks, podcasts, or whatever, seems to be very unreliable. So, the average citizen probably has down calibrated everything that they hear about nutrition. I think that they may read about nutrition and say, well, we've been fooled in the past. This seems to be just more of the same. We're not going to pay much attention or no attention. And others maybe just belong to some clan that believe that they know everything about nutrition, and no matter what, they will follow that advice or other. So this is one example of a field that that has lost credibility both within science but also within the community, unfortunately. We saw pandemic response science losing credibility in large segments of the population and gaining credibility in other segments of the population for the wrong reason, not because it was rigorous science, but it was something that one part of the community had to fight against the other. So whatever
Mhm.
one part was espousing, the other had to fight against, and this could become a dipole of very non-scientific deliberations. It was more like a belief system, like two religions fighting each other. One had to be right all the time, the other had to be wrong all the time.
Mm.
As a response, we just see that the outcome was not congruent with what we would have hoped. I think that we got outcomes that were far, far suboptimal because we just could not get the community, the people to really be on board and to really feel that we're all in the same boat and we're all trying to do our best. Very quickly that notion was scattered to the four winds, and it was thought that it was conflicts, interests, political interference, misinformation, disinformation, or a mix of all of that was running the show. We have many examples, unfortunately, and I don't think that it is helpful to lament
Yes.
about what happened. Hopefully, trying to learn from failures shows we can do better in the future.
Mhm. Okay, fair. Let's not list all of the challenges, but I do want to drill down on one in particular. You mentioned the pandemic. Could you just give us an overview of what you think some of the, from a methodological and the, epistemic standards behind some of the evidence? What were the standouts? And then I know you also had, an intervention during this time, or a number, I'm sure, um, that drew obviously some attention and some praise and some criticism. So I'd love to hear about that from you.
Well, I think that this is a very long story, but science was mixed with a lot of fear, panic, emotion, politics, conflicts, animosity. Some of that very humanly justified. When you feel that you're at risk of dying, and your family is at risk, and your friends, and your world is collapsing, or your world is threatened. By measures or by the virus or by both, then people will react in ways that are probably not the best of rational human behavior. At the same time, we had a massive scientific effort. We had about 2 million scientists publishing on COVID-19 over these 5 years. We just published some updated numbers on that literature, and that was close to 1 million scientific papers. Most of them were not of very good quality. Most of them were very quickly done. Many of them had not sufficient expertise in the background. Let's say that people were very well intentioned, but they didn't really have the skills to work in epidemiology questions or virology questions that they tried to attack. Many of them were just cutting corners. Very often we saw that within days, sometimes hours, journalists and influencers and scientists who were more influencers rather than scientists, or behaving more as influencers, took over the control of what was going on. And for people who were trying to do research, the research takes time to collect information, to validate it, to analyze it, to vet it, and then try to publish it. Conversely, if you're an influencer, you can say whatever you want, and you can amplify your message very, very quickly. And you may have the venues to do that, either legacy venues, legacy media, and sometimes legacy journals like Nature and Science have most of the things that they publish are journalistic articles, rather than scientific peer-reviewed papers, or new types of media that may be more inclined to sometimes very paradox ideas. Occasionally, occasionally they may be right, but very often they might be wrong. Um, so that was a very explosive mix, and trying to do science the way that science should be done very carefully with the right amount of uncertainty, as I said, with careful controls and self searching about what might be wrong here. How can I correct this? When you're outnumbered and outpaced by all these other forces that seem to be generating scientific information or what seems like scientific information, it's very difficult. I think it's next to impossible. And of course, policymakers, they're not educated to be able to discern what is rigorous science and what is just science in quote. They say, follow the science, and we have these experts and they're telling us what to do, and we can even throw some of the blame to the experts if need be. And and we go with what eventually were mostly very irrational and goodness horrible decisions. Of course, not all of them, because
Mm-hmm.
probably millions of decisions were made. Some of them
Mm-hmm.
were probably pretty good,
Yeah.
but most of them had no scientific justification. Probably many of them actually did harm people rather than offer them some benefit.
Wow. Fascinating. I want to ask you now, John, because there are a number of different facets of these challenges you've touched on. There are methodological issues in the sciences proper. There are all of these social, confirmation bias types of problems. And then there's the communication and kind of the science policy interface. What are the major improvements you'd like to see in this area going forward?
I think there's not a single improvement. There's many improvements that have happened already, and we know that they work in some specific fields. So let's say if we put them into large bins, one is how to uh, have an agenda for research and how to design research. The other is how to run and to report research. The third is how to review what we do, how to evaluate. And finally, the overall rewards and incentives. So all of these are interrelated. And to give you an example, if we have the right reward system and the right incentives, we can hopefully get scientists who do better work, better quality work, more rigorous, more self-reflective, with more attention to correcting or preventing biases, incentivized and rewarded. And conversely, we can try to perhaps penalize fraud or outright fake types of research or highly problematic research. So incentives can affect both the agenda and the design and the conduct and the reporting and the dissemination of research. Now, in each of these steps, there are things that we can do that could do things better and things that we could do that could make things worse. We do have tools. Take reporting, for example. We have a large number of reporting tools, reporting guidelines on how to report how research was done, so that people can understand, how, can have transparency and see what was done, and then can probably tell that was done correctly or that was suboptimal. Let's see how that might affect what results we got. If you go to the Equator website, Equator is an organization. I'm director of the US Equator Center, where we try to collect information on all these types of guidelines. You can find guidelines for almost any type of research on how to report it. And now we have also guidelines on how to design studies that are very meticulous, very thorough. They're not followed most of the time. So I think we can do more to try to get more of that knowledge to be part of the average study being done. Some types of research that are not exploration, where we have a very clear goal, a very clear outcome set in mind, we want specific questions to be addressed, we can have very detailed protocols. They can be pre-registered. That seemed to be like an out of the box idea 30 years ago, but now for randomized trials, it's the norm. People have to register a randomized trial ahead of time. I think it has made a difference. I think it decreases the degrees of freedom where bias could creep in. Some other domains are even exploring more rigorous approaches like register reports, where you don't just register the protocol, you practically write the paper ahead of time without the numbers, because you don't have the numbers yet, but you say, this is exactly what I'm going to do. And this is what table one, table two, and three are going to be. I don't know what the numbers will look like. That's why I'm running the research. But I know exactly what I'm trying to do. And so if you have a very confirmatory type of validated outcome-oriented type of research, this may be a good idea. It gives an opportunity to be very rigorous. Decreasing conflicts of interest could make a huge difference. Who is doing research, and it's not an issue of having good people and bad people, or good organizations and bad organizations. All of them can be good and all of them can be bad depending on what step they're introduced in. So, big pharma is not evil. Big pharma is trying to develop drugs, vaccines, biologics that may help people. That's great. One can save lives. But if you tell them you need to do research that will prove that your drug will become a blockbuster and it's you who have to support that research, they will just do their best to do everything in their capacity to get a nice looking result. So
Yeah.
so we need to remove that temptation from them. Give opportunities for them to do the research to develop these new technologies, but have independent investigators who test these interventions to see which one works and which one works better than the others. It's a very vast landscape, and I think that we need to question and revisit what we do at every step. Every step is an opportunity to do things better, potentially. And I think that fields that are reflective are likely to make more progress in that regard.
Hmm. Yeah, well, transparency is a recurring theme on the regulation and the design of studies and what have you, and certainly humility and clarity with respect to how results and justification of next steps is communicated has been another. And I would say, John, you're very exemplary of that, in how you speak about these issues is quite refreshing. We could all use more of that in the political and public policy domain. I can attest to that. And it's been a real pleasure having you on. Thank you for joining us amidst your travels. And I'm Peter Copeland for Inside Policy Talks. Thanks everyone for joining us.
Thank you so much.